Nitrogen stabilization, and you could also, by extension, speak of carbon stabilization, because the reality is you're stabilizing all three of these anions together, these protein and carbon-based compounds will be unstable relative to the lowest common denominator. They're dependent on the lowest common denominator. So what I mean by that is, let's say, for the sake of discussion, that you have your soil holds a reserve of 60 pounds of nitrogen, and you apply an additional 60 units of nitrogen. So now your soil profile has a total of 120 units of nitrogen in the top 6 inches. I'm just making up a hypothetical example. So you have 120 units of nitrogen, and you have 8 pounds of available sulfur. When in reality, to maintain the 10-to-1 ratio of nitrogen to sulfur in the soil profile, you are now missing 4 pounds of sulfur. So those 4 pounds of sulfur that you are missing, so you have 8 pounds of sulfur, that means you can hold 80 units of nitrogen. Your soil already had 60, you added 60 more. But of those 60 that you applied, you now have a total of 120. That 120, 40 pounds of that nitrogen, 40 out of the 60 that you applied, is going to remain soluble as nitrate or as ammonium. Nitrate, of course, is the most leachable. And so those 40 units of nitrogen can move through the soil very quickly and very easily because you don't have enough sulfur to hold them stable. So there's a very simple remedy for this. If we just simply apply sulfur at the same time that we apply nitrogen, we now give the bacteria in the soil profile the resources that they need to form and to convert all that soluble nitrogen into the amino acid form, and we don't get nitrate leaching. And of course, when we speak to the lowest common denominator, it is also possible that the lowest common denominator can be available carbon, particularly in sandy soils. So when we have soils that are low in organic matter, have very large particle size, then having adequate carbon to bind the nitrogen can be a challenge, particularly when we don't have a green growing crop. So when you have a crop that is green and has a substantial amount of vegetative biomass, generally, if it's a healthy crop, it should be contributing a substantial amount of carbon to the root system and moving out into the rhizosphere as root exudates. If that is happening properly, as it should be, then generally you are supplying a substantial amount of carbon from living root biomass and from root exudates.